Hi, everyone. My name is Dave DeLong. As Patrick mentioned, I am a senior iOS engineer at Snap, but mainly I'm a guy who likes to think too much about things. So before we get started, there are a couple of things I need to warn you about with this talk. First off, I need to do a shout out to our legal and PR departments that the thoughts expressed in this presentation are my own opinion and do not necessarily reflect those of my employer or others who work there. Hi, legal. The next step, I'm going to be using a lot of familiar terminology in this talk, and a lot of it is going to kind of maybe cause some confusion, so let's clear things up right away. First off, I'm going to be talking about views. I'm also going to be talking about UI views. And I want to make sure you understand up front that when I talk about view, I'm talking about the view in the MVC sense of a view, of a thing that does UI-related things. It is not necessarily the same thing as a UI view. So if you watch the slides, I've tried to do a good job about making sure that when I'm talking about a UI view, I'm using a code font, and a regular view is just a normal font. Same thing with controllers. I'm going to be talking about controllers. We also have UIViewController. Again, they're not necessarily the same thing. But I hope that the concepts that I talk about today will all sound familiar, especially after listening to the talk earlier today about app architecture. This should all be pretty familiar. So let's talk about MVC. MVC, as we know, is a standard Cocoa architectural pattern. It's also been around much longer than Cocoa has. And we have this diagram that Christoph hates, where you have the controller, and you've got your model, and your controller talks to your model, and your model talks to your controller, and then the controller turns around and relays that information onto your UI, and then gets events back. So this is like, of course, the high-level thing we can hand wave of like whether this is correct or not. But one of the things I want to point out is that we talk about this being a pattern, but it's not really a pattern. It's more of a philosophy. It's a way of thinking about things. And the philosophy is that MVC says that we need to separate concerns. So what does that mean? It means that our storage doesn't know about our networking, and our networking doesn't know about parsing, and our parsing doesn't know about routing, and our routing doesn't necessarily know the specifics of our business logic, and the business logic doesn't necessarily know how things are rendered. Like, these are all separate areas of concern in our app. And this is the philosophy behind MVC, that we separate all of these things out. However, MVC, of course, is easily abused, and the common example is that MVC doesn't actually mean model view controller, but it means massive view controller. And this is a problem. Massive view controller is the idea that you have a UI view controller and you start loading things into its behavior, such as dealing with loading your views or your zibs or your storyboards. You implement IB actions. You've got model observation. You've got networking and callbacks. You have your data sources to supply information to your table view or collection view. Then you have delegates to handle reactions to that. And of course, you have trait collections, because this might be a hybrid or iPad and iPhone app, or supporting multiple size classes. And then, of course, there's actually also the logic that makes your app your app. The problem with Massive View Controller is that your code is hard to understand. Nobody wants to open up a file and discover that they're dealing with a 7,000-line view controller. You have no idea what's going on. You can't really isolate functionality to test it. You can't isolate functionality to change it reliably. It's hard to work with. It's hard to test. We deal with these view controllers where 2,000 lines of code is common, and that's a travesty. And we also run into situations where we have 10,000-line view controllers, and when we come across one of those things, we just don't want to live on this planet anymore. Because who wants to deal with 10,000 lines of tightly coupled code? But what if I told you you could fix MVC? So let's talk about how we could make a better MVC. Now, one of the principles I adhere to really closely is that when I'm faced with a problem, to not just throw it all away and start over from scratch. So don't rewrite, let's refactor. As engineers, we have this tendency that we come across something we don't understand, and so our gut instinct is to try something different. And this, sounds really nice because then we're dealing with something that we understand entirely, and it's all up to us. But let's not do this. Let's refactor MVC. We're going to make iterative changes to MVC and arrive at a better pattern. And we're going to do this by making 8 observations. So, observation number 1. Patterns are like data structures. So let's talk about data structures really quick. So when I talk about data structures, I'm talking about ways to organize your data. So they have performance characteristics. We know that if you've got an array and you want to find, or you want to get an object at a particular index in that array, it's a constant time operation, just jumping to that index. However, if you want to find a particular object, that of course is linear time. So different data structures have different performance characteristics. They also have different memory characteristics. So the amount of memory you need in order to implement a data structure affects, its capabilities. But choosing the right data structure means that it makes certain problems really easy to solve. So if I need a data structure that says simply, have I come across this thing before, then I probably want a set, because I can have constant time lookup, that's fast, whereas using an array would be linear time lookup, which would be slower. If I'm only dealing with like 10 objects, it doesn't really matter, but if I'm dealing with thousands of objects, that's very important. So choosing the right structure makes the right things easy. Now let's talk about code structures. Well, code structures also have performance characteristics, and it has a couple of different kinds of performance characteristics. There's the performance characteristics at runtime. How you organize your code and like how many layers of abstraction you're dealing with affects how fast your code runs. The more layers of abstraction you have, the slower it's going to run. This is why people still write in assembly, because there is no abstraction at that point, pretty much. There's also the performance characteristic of you as the coder. If you're dealing with unfamiliar patterns and unfamiliar structures, then your performance as the coder drops. You cannot be as efficient. There's memory characteristics. So again, the more abstraction, the more structure you have, perhaps the more memory you're going to be using. And again, for the coder, the more arcane the pattern, the more memory is required to understand it. And again, choosing the right structure makes the right things easy. There are situations where an FRP approach to solving a problem is absolutely the right thing to do, even at the cost of it being different from how you typically might solve a problem under other circumstances. But the right structure makes the right things easy. So how do we choose the structures? Well, when it comes to data structures, it's hard to go wrong with array, set, and dictionary. There are situations where you want something more obscure like a self-balancing tree, or a doubly linked list, or something like that. But in general, we start with array, set, and dictionary, and only move to something else if we can prove that these will not meet our needs. And I would propose that it's also hard to go wrong with MVC. That if you're looking for a place to start with MVC, and then once you've proven that it's not going to work, move to something else. Because other patterns are also valid. Things like FRP, or Viper, or Discover, and MVVM fits in very nicely with all of this as well. These are all relevant patterns. They're all tools in our toolkit. So in order to make these decisions, we need to spend the time learning their respective strengths and weaknesses. So that's observation number 1. Observation number 2 is that our naming affects perception. So there's a joke that the 2 hardest problems in CS are naming things, cache invalidation, and off by 1 errors. naming things is hard. How much time do we spend bike shedding names? Like, you just need to go look at the Swift forums to see how big of a problem this is. Should this be contains only, or should it be all, or should it be all matching, or we spend an inordinate amount of time naming things. So for example, if we come across a class that starts NS star, it's probably not going to be a UI concept. It's probably going to be more at the controller layer, maybe the model layer. It might be UI. Of course, it would be UI if you're writing a Mac app. But we can make an assumption that it's, how it's named affects where it's used. Ditto, if we come across something that starts with UI, it's probably going to be a view-level concept. We do like calling things controllers, and we assume that if it has controller in the name, it must be a controller. And we kind of use this as a default thing to name things. If it's not in our model, and it's not a view, well, it must be a controller, and we end up where everything is a controller and nothing makes sense. And this is bad. And sometimes we'll run out of things to call controllers, and so we'll name them managers and set it and pat ourselves on the back because we've solved that problem. And then we get into other weird situations where we kind of like reach across the concern separation and we call things view models. We have model controllers as well. We of course have view controllers. We might even have controller views, and naming is weird. So this is just an admonition. Please choose good names. Observation number 3. UIViewController is not a controller. And before you break out your pitchforks and come at me, let's look at what a UIViewController does. First off, it loads views. It shows views. It lays out views. It rotates views. It transitions between views. In fact, it pretty much only does things related to views. Well, if it only does things about views, maybe it's really a view and not a controller. I want this to sink in, because this is definitely at odds with how UIViewController is positioned by Apple, by the sample code, by the documentation. But what are the implications of this? If we consider the notion that a UIViewController is not a controller in the MVC sense, what does that mean? Well, it means our view controllers shouldn't have any networking code in them, because why would you put networking in a view? It shouldn't be concerned about data persistence, or even the specifics of how your UI is laid out with respect to navigation between screens. There shouldn't be any business logic in your views. You shouldn't be directly dealing with your model. It's all just displaying stuff. So those are the things it shouldn't be doing. So what should it be doing? Well, it should be receiving an intention from a controller. And I'm going to use the word intention a bit, meaning kind of what you're hoping to accomplish. So it receives an intention from the controller. That intention can be put this profile data into the UI. And so it takes that intention, that data, breaks it apart and puts it into the constituent UI views. It implements some rudimentary IB actions to deal with selection or button tapping and so on. And then it translates those actions back into a corresponding intention, and it relays them back out. So the question then is, if a view controller is a view, then you can kind of think about it as just a little bit more complicated UI label. So would you do networking or data persistence or business logic in a UI label, which is also a view? And if the answer is no, then chances are you probably shouldn't be doing it in your view controller either. Observation number 4. Views are small. Now, when I talk about small views, I don't necessarily mean code size, although we are arriving at that through this approach. I'm talking about it from their physical size, their dimensions on screen. The view is a unit of UI, and you use a lot of these units to create the UI of your application. And you don't have a single view for your screen. Your screen of your app is composed of many UI views, hundreds of them, in fact. And so we want to take this concept of a small view and mean small UIViewControllers. And this is something I really want you to understand, that a UIViewController does not have to fill your screen. It is not equivalent to the screen. You don't have to fill the screen. Or in other words, you can show many view controllers on the same screen. Or a single screen can show lots of view controllers. This is, I think, a concept most people don't get because, again, the sample code emphasizes the notion of, like, you have a UI table view controller, it fills the screen. You have a UI navigation controller, it fills the screen. You have a UI tab bar controller, it fills the screen. Split view controller fills the screen. Page view controller fills the screen. This does not have to be the case. A view controller, a UI view controller, could be 10 by 10 pixels, or points, I guess. And if that's what it takes to simplify the view side of your application, then you should do that. Does not have to fill the screen. Observation number 5. Views are composable. So composition is the idea of adding together lots of little things to make a big thing. And its inverse is decomposition, which is taking a big thing and breaking up into littler problems. And I would suggest that composing, the ability to compose and decompose, is the singular skill that makes you a good coder. It's not really how many languages you know, it's not really the frameworks you know, it's not the tools you know how to use, is can you break problems down into smaller steps, can you solve the smaller problems, and can you put those small solutions back together to make a big solution. All good coders, in my experience, know how to do this really well, and the bad ones don't. So let's talk about how we can compose UIViewControllers. Well, there is an API that deals with this called Add Child View Controllers. It was added in iOS 5. So you literally have no excuse to not use this because there is no app you are shipping today that does not support iOS 5. And the idea around child view controllers is actually it's manifest in a bunch of key APIs in UIKit. All navigation, whether it's tab bars or split view controllers or navigation controllers, is done through child view controllers. UI search controller looks really weird at first until you realize it's using composing view controllers, and then it gets less weird. Still a little weird, especially how it mucks with navigation bars in the search field that slides in. Still weird, but it's about composing view controllers. I also throw UI refresh control up here as well, because if you remember, when UI refresh control first came out in iOS 6, it could only be used on a UI table view controller. This was really intentional, and I know because I wrote it this way. We had just introduced child view controllers in iOS 5, and we really wanted to incentivize people to use child view controllers in iOS 6. So we have this new control, UI refresh control. Let's put it in the API in such a way that you have to use view controller composition in order to use it, because you could only use it on a table view controller. This didn't work out quite so well for a couple of reasons. But there was a method to that madness. Okay, observation number 6. Views are reusable. When I talk about reusing views, I don't necessarily mean the reuse in the sense of UI table view and dequeuing reusable cells and stuff. I'm talking about reuse in the sense of allocating multiple instances of this. So whenever we want to display text on the screen, we do not subclass UIView and create a new UI label variant. If we want something that's interactable, we do not subclass UI control and create our own custom UI button. So why are we always subclassing UIViewController to create our own view controllers that are only used in one place? I would suggest that that is not how it's supposed to be. I would say let's write our code with the expectation that we are going to use a view controller in multiple places. All of the views provided by UIKit are built in such a way that you use them all over the place. Anywhere you need a spinner, you use an activity indicator. Anywhere you need a progress bar, you use UI progress bar. Anywhere you need a slider, you can use UI slider. You don't have to create a custom version for each of these cases. So what does this look like? Well, if we consider a couple of different scenarios where we have these view concepts, let's see if we can pull them apart into more reusable components. So for example, if we're writing a Twitter app, assuming they haven't killed the API yet, we might want to write a tweet list view controller. But that would be a sort of thing that would really only be used once. So instead, let's make a list view controller that happens to show tweets. Or it maybe could show lists of users, or it could show a list of hashtags or filters and so on. So instead of a very specific concept, we can make a more general concept that's then reusable in many places. We see this a lot. We have a UI image view subclass that will go hit the network because we've given it a URL to download an image, and so it's going to do this. But maybe instead of like this custom UI image view, we've got an image view controller, because again, a view controller doesn't have to fill the screen. It can be even just the size of an image view. And it's got some sort of protocol-typed image provider. And then suddenly we've got this asynchronous loading image everywhere in our app. Or instead, if we've got a list that asynchronously loads, we will do things like we'll remove a view from the view hierarchy or just hide it and throw an activity indicator that's centered into the screen and maybe do some fading stuff. Well, that's really just a container controller that's transitioning between multiple children. So it's a container controller that's got some sort of list view controller. It's got a loading view controller that's just the activity indicator. It's maybe got an error message view controller if something fails. And it's just a container that's fading in between a different child. So this is the idea of building a UI view controller that can be reused in many different ways. So this sort of container view controller is literally just it shows another view controller and would fade between the old one and a new one. And that sort of thing is highly reusable. Okay, 7th observation, 2 more. Views show data or they have children. Let's talk about how we build views. Views generally do one of two things. They add logic and layout by composing other views, or they draw stuff. And this is the case for all UI views provided in UIKit. So for example, UI button. We use it as a single thing, but in reality, UI button is a whole bunch of different composed views under the hood. It's got image views for drawing borders. It's got a label for drawing the text. It's got an image view for showing selection state. It's got another image view if you've set an image for a various control state. So it's really just a massive composing view. Even something as simple as UI progress view, just the progress bar. This is a container view with generally 3 image view subclasses. It's got a left cap, a right cap, and then a stretchy image view in the middle. And so when you're changing the progress of a progress view, it's really just changing the width of an image view and then stretching the image. And that's all there is to it. And so UI progress view itself is really just dealing with some layout. Even something that's complicated as UI text field, same sort of thing. When it's not in editing mode, it's literally just some image views and a label there in the UI text field. Once you start editing, then it brings up this thing called the field editor, and the text system kicks in and that's all weird, but the text field itself is just composing other views. When we build the UIViewControllers provided by Apple as well, they generally also follow the same pattern. So again, view controllers either put data directly into their constituent UI views, or they compose other UIViewControllers. There are some exceptions to this. There are cases where we come across UIViewControllers that both manage children and put things into UI views. So for example, a tab view controller manages the children of its tabs, but it also draws the tab bar. You could build UI tab bar controller in such a way that the tab bar is actually a private child view controller, and then it's responsible for drawing the tabs. Ditto navigation controller and its bar and stuff. But generally, this is how you build view controllers. They either put stuff into views or they have other children. Okay, observation number 8. We've done all these things, we've made all these observations, and what we realize is we still need controllers. Or as we were hearing about earlier, they can be called flow coordinators and stuff, because all of this stuff that we've been talking about in MVC is really just focusing on the views, right? We haven't really talked about how to structure the routing logic that goes into your controller, or how to organize the data persistence of your model and so on. So the question then arises, where is this logic? Well, this approach is really going to dumb down your UIViewControllers. You're going to end up with view controllers that are really small, because they never know how they're being used. They're just given data, and they put stuff into their views or pass it on to new children. So they don't necessarily know, oh, I'm on the profile screen, or I'm looking at the details of a tweet, or so on. So in order to get the actual logic of our app, we still have to delegate this intention out to our controller layer. So there are a couple ways we can do this. We can either do delegation, or we can pass around prototype controllers, and so on. And so we're going to take a look at this by doing a case study. And this case study is an app that I know very well. It's the WWDC app. Hopefully you know it well as well. So this is the session detail screen of the WWDC app. This is multiple screenshots stitched together. This is not a super tall iPhone. Yeah, no secret leaking going on here. It's just multiple screenshots. On this screen, there are a bunch of things going on. We have the ability to watch a video. We can read session information. We've got some contextual actions. We can look at related sessions. And all of this is manifest in code as we've got our logic. So we observe model to know if the title or the description changes, because it can update dynamically. We determine what actions are contextually relevant for a session. We have to observe some state with these actions to know, is this download in progress? Is it already downloaded? So I need to remove it, or do I need to initiate a download? We, of course, discover the related videos. And then the actions that we perform on this, we can favorite a session, we can share a session, we can watch the movie, and then perform the contextual actions, and of course watch a related movie. So a bunch of different things going on this relatively straightforward screen. Now, if we were to build this as a single view controller, this would be terrible. Let's not build this as a single view controller. Because remember, if we wouldn't make it a single UI view subclass, then it probably wouldn't make sense to be a single UI view controller either. So how would we break this up? Well, we've got the overall main screen. And this screen is divided up into a few different areas. We've got the poster frame at the top, we've got the title, we've got the description, and the title and description I would consider separate just because their positioning changes when you rotate. We've got the list of contextual actions, and we have the list of related videos. So let's make those view controllers. So we have a session detail view controller that's really maybe just a variant of a stack view controller, because these are all pretty much just laid out in a stack, although it does get a little bit more complicated if we rotate. And then this has children view controllers, the poster view controller, title view controller, description, actions, and related videos, related content. So as we're dealing with actions and passing data around, we've got things where, we've got our controller, and I am just going to kind of like hand wave over what that is, because that's a whole different third part of our app. So we've got our controller, and it's going to give us some sort of session object. And this session detail view controller is then going to turn around and just instantiate those 5 children and give them each a copy of the session information. And then that title view controller is going to pull out the title, the description view controller will pull out the description, and so on. Now, when we need to get actions back, we can perhaps, one way to do it is by setting up delegates. So our session video poster view controller delegates to the detail view controller delegates to a controller, and then we have some action, whether it's tapping a poster, tapping a related video, those get passed up to here. This then recontextualizes what that intent is. So instead of getting a message of just like, hey, the user tapped on this button, we're now going to translate that into the intention of, we want to watch a video. And so at each layer, we're dealing with the semantically appropriate way to describe this information. So this is approach number 1. Approach number 2 would be more of a dependency injection sort of approach, where we've got the detail view controller, and then we receive, again, somehow, I refer back to the earlier talk on how to do this, we receive these sort of protocol-typed objects that are used to receive the intention directly. So instead of delegating up layers through the various view controllers, we can kind of bypass directly to the controller layer, and again, translate this tap a poster into whatever action is appropriate for those objects. So this is how we can make a better MVC. We've made these series of observations that patterns are like data structures, that UIViewController is not actually a controller in the MVC sense, that our view controllers and views should all be reusable, that they should rely heavily on composition. And when we apply all of these things to our apps, we end up with some really interesting results. We end up with really tiny view controllers. And when I say tiny, I really mean tiny. Like the smallest view controller I've written in this approach was 4 lines of code. There was 1 line to declare the class, a 2nd line for an init method that really just called super.init with nib name nil, bundle nil. I just wanted a plain old initializer. I had to have a 3rd line because Xcode makes me put in init with coder, and that just fatal errored. And then a 4th line for a closing brace. All this just so I could have a nice init method. But that's really it. And then the entire UI was just loaded from the zib for the view controller. And it just happened automatically. This was in particular a view controller that was an activity loading state. So it was really just an empty view controller with a spinner in the middle that started automatically. So no code necessary, 4 lines of code, but I could use it anywhere I needed to indicate asynchronous loading going on. But generally, your view controllers will be under 200 lines of code. And if you follow this approach, you will get to the point where 300 feels long, which I think is a really good place to be in. Second, you will find that you rarely ever subclass UIView. I'll bet if you were to go take an inventory of your apps, you would have dozens of subclasses of UIViews, just because you're using UIViews to do custom layout. Once you move UIViewController down to the view layer, you can realize that you can just do all the layout in the view controller, and you never have to subclass UIView again, which I think is really nice, because it means you have more influence on dynamically choosing layout with regards to life cycle, trait collection stuff, and so on. The only time you ever really need to subclass UIView with this approach is when you need to fundamentally draw things differently. So like you need to use a different kind of CA layer to back your UIView, for example. you end up with extremely reusable UI view controllers. So like I was talking about this 4-line view controller to indicate activity progress. That's an example. You end up with a view controller where like you just give it a new child view controller and it will just fade from an old one to a new one. Or you have a view controller that's literally just like, it shows a list. And maybe that list is made up of other child view controllers. So you're dealing now with view controllers as cells in many cases. So you get extremely reusable view controllers. And I think even more valuably, you get a clear separation of concern. You look at a view controller and you know, I'm displaying a list. I don't have to worry about the details of how this tweet is getting laid out, or whatever. It's just I'm displaying a list. And it allows you to really focus on the problems at hand and make fixes that are appropriate, that don't have cascading effects. And so ultimately, you get happy programmers. You get code that's nice to clean. It's nice and clean, and then you're happy to work on because it's beautiful. It's small. It's focused. It's fun. It's not a 10,000-line view controller, and that makes me happy. And I hope it would make you happy too. So, thank you for listening. If you have any questions, you can come up and find me afterwards. And I think I've ended a little bit early, so we can get to lunch a little early. Thank you very much.